And now we're going to look at this limit of a piecewise function. Okay, now here's a kind of jagged sketch of a piecewise function. A couple lines, okay, connected or not connected, at whatever the case might be. So we've got from -2 to 0, we're at x plus 1, but we're not defined at the endpoints, okay? From 0 to 2, we're along the line -x. At x equals 0, we're at 2. So we're moving along. For this single value of 0, we jump up to 2, where we're defined, and then moving from 0 to 2, we jump on this graph -1. Then at 0, at 2, we jump back to here to the y to the x value of 2, okay, which is the y value of 0, and then we continue on this x minus 4 between 2 and 4. So all we know of this function is from what we can see here in its description and the graph provided, okay? So typically, piecewise functions are going to be asking questions about limits at those points where the pieces connect. At the points where the pieces connect. So they do, keeps happening, I'm sorry about that, okay? So we do connect at 0, we have another connection point at 2, and then we have the endpoints, which we're going to ask the limit questions on, okay? So the first one, the limit as x approaches -2. Well, we don't know what's happening on the left side of -2. We don't know whether the function is terminated at this point or not. So we don't know, we can't make any assessment as to what is going on the left side of -2. Therefore, we can't make any judgment call on the left-hand limit at -2. The right-hand limit as x approaches -2 does definitively give us -1, but the left-hand limit is undefined, so the limit as x approaches -2 is undefined. Next, we ask what happens as the limit as x approaches 0. Okay, well, again, to evaluate the limit as we approach a point, we have to look at it from both the left and the right side, okay, from both the left and the right. Looking at it from the left is to imply, okay, that the function value is moving towards 1. Looking at it from the right side as x approaches 0, we're finding that the function value is equaling 0. So therefore, since the limit from the left goes to 1 and from the right goes to 0, we're going to conclude the limit as x approaches 0 is undefined, okay? Does not exist. All right. Now, next question, what happens as we approach 2? Here's our x value of 2. F of 2 is 0. It doesn't matter. We're not concerned with what the function value is evaluated at this point, x equals c, in this case x equals 2. We're asked what happens as we approach that, as we approach x equals 2, okay? From the left side, we're approaching -2. As we approach on the function the x value of 2, moving along on the x-axis, approaching 2 on the function, says that the function's moving towards -2. So therefore, since the left side moving towards 2 is approaching -2, and since the right side moving towards x equals 2 is approaching -2, the limit as x approaches 2 of this function is going to be -2. Even though at 2 it's defined as 0. Again, we're not concerned with how the function is defined at this value. We're concerned what value the function is approaching as we get closer and closer and closer from both the left side and the right side of that point in question. Lastly, we're asking, what is the limit as x approaches 4? Well, we have the same kind of situation as we asked when we asked the first question, what happens when x approaches -2? From all we can see is on the left side, we have no idea what's happening on the right side. So from the left side, we're saying, okay, as x approaches 4, the y value is going towards 0. But I have no idea what's going on the right side of the function. Therefore, I can't evaluate the limit, the one-sided limit, as x approaches 4 from the right side, and therefore I cannot make a definitive conclusion about what happens as x approaches 4, okay? Because the left side is known, the right side is unknown, okay? All right? And again, this is a detailed description of what we just asked there, okay? And the last item there says we can evaluate it from the left side, okay? But we don't know about evaluating it from the right side, okay? Now, in some instances, all we can do is evaluate it from one side. So all we can do is a left or a right-hand limit, okay? We can only create a left or a right-handed limit, one-sided limit. So we consider our graph of the function, the square root of x minus 2. And we ask, what is the limit as x approaches 2 for that function? Here's our graph, as we well know, and of course, this serves as a good reminder of function translations and the like, okay? This is a translation of our function, okay? The square root function 2 units to the right, okay? Now, if I'm going to ask, what is the limit as x approaches 2? Okay? It would make absolutely no sense to say, well, I don't know what's happening on the left side of 2, so therefore I can't make a judgment call on the limit. Well, yes, you can, because we know that the function is not defined for x less than 2. There's no portion of the function ever existing. We know that. The function only exists for x values greater than 2. So we're not going to even consider taking the limit, the left-hand limit, as x approaches 2. We're not going to say it doesn't exist. There's no reason for it, okay? So therefore, the function notation, the function definition precludes us from having to take the left-hand limit, all right? So in this case, we're going to say, and in any case where the function, the definition of the function precludes us taking both left and right-hand sided limits, that the limit as x approaches 2 for this function is 0. Okay? Some would like to argue, oh, well, but the left-hand limit does not exist. Well, the function does not exist. So there's no need to take the left-hand limit as x approaches 2. Okay? An even better argument is probably with limits moving towards infinity. Okay? So when we're addressing one-sided limits going towards infinity, you can't, okay, if I'm saying, okay, well, what is the limit as x approaches infinity? Well, you can't come at infinity from the right side, okay? How can you approach from the right side of positive infinity or the left side of negative infinity? So I mean, those things are just intuitive in nature, all right? You can't have left and right hand limits, okay, at infinity. It's either one or the other, all right? So, and as you should recall, we have mentioned earlier in our discussion of asymptotes that when we're talking about asymptotes, we are basically talking about limits as x goes to infinity. So our special cases for when only one-sided limits might be examined, okay, would be, you know, at these points where either a function is initiating or where a function is terminating at infinity, if you will, okay? So those things hopefully do not create a problem. They're more intuitive in nature, and so therefore those one-sided limits would be all that's required in order to evaluate the limit at said point. Okay? We'll come back and look at some examples in the next video.